Off camera, I set up this spreadsheet with the intention of demonstrating to you how the concept of internal rate of return works. Up until this point in my videos, I've always specified an interest rate or a discount rate or a cost of capital that's used in these calculations. The logic of the internal rate of return is simply, why specify an interest rate or a rate of return or a discount rate or a cost of capital, when instead you could take a look at a series of cash flows and then calculate what the rate of return was for that set of cash flows. In other words, instead of us telling our investment what interest rate or discount rate they're using and us comparing the result to that discount rate, that cost of capital, we're going to find out what the rate of return is, what the interest rate is, just by looking at the numbers sitting in front of us. So basically, here's what we've done. I just made some numbers up for illustration purposes. We have $90,000 going into an investment into a business enterprise in year 0, and every year running that business costs us money, and then by year 4, things start turning around, and net, we start having more money flowing out than in, and by the time 10 years are over, we've started bringing in some really nice dollar figures. So imagine this is what your first 10 years of running your business looks like, and that looks pretty good to me, especially after about year 7, year 8, the numbers start to look real nice. And so here's what we're going to do. Let me pull a formula and stick it up on the screen. I just typed this formula up in Microsoft Word so we can quickly pop this up here. This is the idea, is to find that magic interest rate so that the sum of the present value of cash inflows, those negative numbers going into the investment, are going to be the same as the sum of the present value of the cash outflows. Now, just so you know, there are some functions in Microsoft Excel that are designed to do this. And basically, this type of thing is too computationally difficult to do by hand. And what ends up happening is an iterative solving process, where when a function in Excel or on a computer figures this number out, it basically picks a number and then raises the number and tries it and sees if that works, then lowers the number and sees if that works, and just iteratively goes through that process of picking larger and smaller numbers over and over again, each time getting closer to that interest rate so that the right and the left side of these two, this equation in front of you, are equal to each other. So let me show you what I mean by that. So I'm going to set up this spreadsheet, and I'm just going to do a real quick present value calculation, PV, open parentheses, click on my interest rate of 10%, hit F3 to lock in the cell reference, comma, click on cell C0 where my period number is at, type a comma. I'm not going to enter a payment, so I'm going to type a second comma so that's blank. And now my future value is my negative 90,000, which I have to make negative for it to display correctly because of the whole cash flow concept that Excel likes to operate on. Close the parentheses, hit enter, drag that down, and we see that we can calculate the present value of all these cash flows. We can discount these cash flows. Now 10% is a pretty big discount rate, so we see those future cash flows not being worth much. Let's do a little bit of formatting, and let's total those numbers up. There we go, and hit enter using the auto sum function, and we get $82,000. So basically what this is saying that if we expect a 10% interest rate, we need a 10% rate of return, that this investment's going to give us a 10% rate of return plus $82,000 on top of that. So just to clarify, if our goal is to get a 10% rate of return, this investment in front of us will get us that 10% rate of return, and it'll beat that rate of return by almost $83,000. And what we've done here is we've done what we've done so far in this video series is we've specified a cost of capital at 10% in this case rate of return, and asked the question, does this investment beat our cost of capital? Does it do better than what we want to get our 10%? And that's one way to set up these kinds of problems and think about these kinds of problems. Another way to do it is a thing called the internal rate of return. The idea behind the internal rate of return is instead of saying, hey, I want to get 10%, by how much do we beat 10%? We instead say, what is the actual rate of return on this investment? So that's what the internal rate of return is. There are different ways to calculate the internal rate of return, and just to be perfectly straight with you here, every method of doing it has some flaw. There's not a completely flawless, perfect way of doing it. And so there's multiple methods we can use to calculate the internal rate of return, and we'll be going over those in subsequent videos. But for now, I want to talk to you about the way one would have done this back in the day before we had a computer. Back in the day before we had a computer, we would have come up with this number, and we would have guessed 10%. And we would have said, okay, we don't know what the actual internal rate of return is, so instead of guessing 10%, we're going to guess 9%, 0.09, and hit enter and see what happens. Well, it went the wrong direction, and I made it as 0.09%, not 9%. So let's try that again. Let's type a 9 there. So it went the wrong direction. The idea is for the sum of the cash flows to be equal to 0, or the sum of the discounted cash flows to be equal to 0. So what we're going to do is just keep plugging in interest rates until we get one that works. So we know it's got to be above 15,000 because our goal is to find the interest rate here that makes this number right here 0. And when this was first done by human beings, it had to be done by hand. Someone had to solve all of this by hand at a million different interest rates to try to figure this out. And what happens now is computers are used to do an iterative solving process. So we have 15 and that number's not right, so we're going to type in 16. And we get a negative number. So we know we have to be somewhere between 15 and 16%. So let's take a wild guess and try 15.5% interest and hit enter. Now we're at a positive number. So we know it has to be somewhere between 15.5 and 16%. So why don't we try 15.75%? And now we have a negative number, so we've gone too far. So we know the actual internal rate of return is somewhere between 15.5 and 15.75%. Let's try a different number, 15.7. And so what we're doing is we're just doing this iterative guessing process, where we just kind of go back and forth until we find out a number that's reasonably close to 0. And this is typically done with computer algorithms. Let's try 15.72 and see how that looks. Well, if 15.72 was too far, let's try 15.71 and see if that works. Well, that wasn't far enough. Let's try 15.715 and see how that works. Well, that's a negative 277. We're not quite there yet. Let's try 15.714. And so what we would have to do is go back and forth by hand over and over again until you reach some reasonable threshold. And honestly, I think $2.77 seems like a pretty reasonable threshold at this point. And we could probably just keep trying different numbers until we got something closer. But I don't know that it's going to actually help us in understanding the problem anymore. We're looking at 15.71% is the internal rate of return for this investment. In other words, the interest rate inherent in this investment is 15.71. And I want you to pause for a second and imagine what it would be like to figure all this out without a spreadsheet, where you couldn't just plug in interest rates back and forth until you get something that works or something that's reasonable and close. That would be a real pain. And I really wouldn't want to do it. It doesn't sound like fun. And so what we're going to do next is we're going to show you the spreadsheet functions, the functions in Microsoft Excel to calculate the internal rate of return, and talk a little bit about the pros and cons of all of these different ones. And this video is just more of a setup of the problem to demonstrate to you that it's computationally intensive and honestly not possible without a financial calculator or a spreadsheet or an app on your cell phone, because going through and doing this iteratively over and over again every time you need to find an internal rate of return would just be asinine. So in the next couple of videos, we're going to talk about the different internal rate of return formulas or functions in Microsoft Excel and discuss the pros and cons of these various functions. Thank you very much for listening. As always, feel free to like and subscribe and say something in the comments. It's very exciting to teach this stuff to students, because every now and then in a classroom environment, a student will raise their hand and say, "Hey, Dr. Gardner, if you do it this way, it's a lot faster." And that means I'll learn a new, faster, and better way of doing things. So if you know of a better way to do something, tell us about it in the comments. I'd love to hear about it. So stay tuned for more videos on the internal rate of return. In this video, I'm going to spin around and make everybody want to throw up.